All right. For those of you who are watching the video, I'm going to go ahead and work this one out. I'm going to give you the validation for each step verbally. And I'm going to draw all over this image because that is the easiest way for me to keep track of numbers. So, A and B wants to know the angle relationship in order to solve for A. So I have one angle that's 40 degrees and a second angle over here that's unknown at this point. But what I do know is that both of these angles share this straight line. And that straight line should be the key, that we are dealing with supplemental angles. And supplemental angles add up to 180 degrees. So I should be able to determine that 40 plus A is equal to 180 degrees. Subtract 40 from both sides, and A is equal to 140 degrees. Now remember also that one of our definitions is vertical angles. Anywhere that two intersecting lines form V's, opposites are considered vertical angles, and vertical angles are always congruent. So if I have a 40-degree angle here, its opposite vertical angle would be 40 degrees. Well, the same is going to be true for A and L. So this one down here would be 140 degrees. Well, let's look for our next angle relationship. I don't know anything about D yet. I don't know anything about C yet. I only have one angle in a triangle, so I need to look somewhere else to see what other information I have. This right angle should stick out to me because that's going to tell me that that angle is 90 degrees. And since that angle is 90 degrees, and I have another straight line right there, I know that angle D and this 90-degree angle are supplemental. They will add up to 180 degrees. So D has to be 90 degrees. If D is 90 degrees and B is 40 degrees, then I can use my triangle Sum Theorem, which tells me that 90 plus 40 plus x equals 180. And in this case, C would then be 50 degrees. So you can see how we're using our theorems and using our definitions, which I've highly encouraged you to memorize, to find the angle measures that are lying in this image. Well, let's keep moving around. I have two angles within this triangle identified, and I'm looking for E. Again, I can use my triangle Sum Theorem. 65 plus 90 plus the measure of angle E. I'm going to go ahead and call X again. Equals 180 degrees. So I will add 65 and 90 and subtract it from 180 and determine that E is equal to 25 degrees. Well, again, we can realize that I have a straight line right here. So E and F share a relationship in which the two angles are supplemental. Their total degrees would equal 180. So 25 plus X has got to equal 180. Subtract 25 from both sides, and F is 155 degrees. Same logic gets us G. I can either consider F and G to be supplemental, or I can see that I have two intersecting lines, so E and G are vertical angles, and G is 25 degrees. Well, now that pulls us into this inner triangle. I have an angle here marked as 90 degrees. And I need to figure out what H is. Well, E and H together would add up to equal 90 degrees, which means that E and H together have to be 90 degrees themselves. So that means E and H are complementary angles. Their sum is 90 degrees. 25 plus the value of angle H is equal to 90 degrees. So 90 minus 25, my H angle is 65 degrees. My 90 degree angle and my I angle, again, we have a straight line, which would make them supplementary. So I would have to be 90 degrees also. And then finally, we have triangle sum theorem here, which says 3 angles would add up to 180 degrees. And we already did this. 65 plus 90 equals 180x. We determined that that third side was 25 degrees. The last angle relationship we have is J and K. J and K are 2 intersecting lines. Their intersections form V's, so we should be thinking vertical angles. Vertical angles are congruent, so their measures will be the same. 25 degrees. Yes, I realize it takes a little bit of work, but you need to work your way through the shape using the definitions that you know in order to solve all the angle relationships and identify the degrees. This is going to be a crucial skill in order for us to get ready for the next section of this unit.